Hey GeeCON, I hope you're there. I can see you because of the blinding spotlights. My name is Sebastian Gebski. I will have a pleasure of telling you a little bit about Java on AWS, some details that matter. And I'm a principal solutions architect in AWS. I do work with startups on a daily basis, and surprise, surprise, many of those startups do use Java. And I do learn that, as a cloud provider, AWS is technology agnostic. So it's suited for any kind of programming language you can imagine. However, it doesn't mean that all programming languages are treated alike in the very same way, because there are always some quirks, there are always some details, there are always some optimizations, because you guess, developer experience matters. So I just noticed how many things people do write code in Java and run this code on AWS do not know. And I decided to collect all of those interesting details that are applicable to you and maybe present them in this particular presentation. You can find my contact info here. Feel free to contact after the talk, after the conference. If you, by some chance, are a listener of the CTO Morning Coffee podcast, or maybe you participate in our live meetings, feel free to high-five me on the corridor after the session. I'm one of the co-hosts, and it's always nice to meet people that you typically meet only online. So, some ground rules for our session. 5 of them. It would be funnier if I generated a picture with 6 fingers, but I have only 5 things. So, well, first of all, I will not just introduce you to AWS or something. That's not that kind of talk. I will talk only about details that are specific to Java JVM developers, or the features that are especially suited for Java JVM developers. So, let's say you are treated as a first top-level citizen for those features, or I will speak about Java JVM specific optimizations for generic features. I will make sure, or I will do my best to get rid of all the fluff marketing, benchmarking, whatever you want to call it, and in the end you will tell me how I did. So if I've actually fulfilled this promise or not. So feel free to, if you learn something, if you really like that, feel free to let me know online or face-to-face. Brilliant. The plan for today is very basic. We'd start with the most, I would say, common things that you should know as a Java developer when you work with AWS. Then we'll talk a little bit about Java in functions, so Java in Lambda. The most important things, for instance, optimizations. We'll talk a little bit about Java in containers on AWS, then about developer tooling, and some other stuff that doesn't belong to any category. And in the end, I will share some resources, some links to things you might consider interesting. And yes, please do use Slido if you have any questions. If we have any time at the end, I will try to answer those. Basics. So what should you know as a Java JVM developer if you use AWS? Well, first of all, I really hope you know that there is an SDK. But maybe you don't know that there is an SDK version 2, even if it's available for already a few years, I think. So it's important for a few reasons. First of all, not because it's your access point to AWS resources, but also because it adds you some very convenient mechanisms like retry and backup behavior. And actually, one important thing that is not mentioned frequently is that it is ready for GraalVM. So if you want a native image, if you want to use a head-of-time compilation, using this SDK will not be an issue. Okay, so this was easy, and probably you've heard about this SDK and you probably use it. But did you know that there is also SDK for Kotlin? And that's an interesting thing. Here's the link, you can try it. It's a separate SDK. It's not just SDK for Java, which is dressed as an SDK for Kotlin. This one is Kotlin native, I would call it. So yes, it does use the common runtime library, which is used by every SDK. But this one, for instance, all the calls are fully asynchronous, and they are run in the coroutines. It does support DSL builders, and many other mechanisms. And also it's packaged in a way that reduces the bundle size. The public roadmap, actually you have the link here. So feel free to take a look there and like bump up any request that you find interesting, or maybe raise your own ideas. It's good to mention this SDK because actually it's considered very highly performant. So even in some cases for Java developers, it's actually encouraged to use SDK for Kotlin just for the sake of the performance. Okay, cool. Talking about SDKs is a good moment to actually mention something which is called Smithy. Smithy is not specific only for Java, but actually Java is one of the few and supported languages. Why? Because Java is used internally in Amazon. So what is Smithy? Smithy basically is an IDL. IDL stands for Interface Definition Language. So it's basically a protocol agnostic, transport agnostic, language agnostic contract definition for the services that are called within the whole landscape, the whole ecosystem of all the applications in Amazon. So if you're asking for something that would resemble this, OpenAPI is actually quite a nice resemblance. So it's a standard how to document interfaces to call the functionalities within the organization. So why would anyone use Smithy, for instance, instead of OpenAPI? Well, the advantage of Smithy is actually that it's transport agnostic. So it doesn't rely on the fact that you like to call HTTP a web API. So this one actually does not make any assumptions about the protocol, about the transport. It's nice, and actually it's intended not only to document the contracts, but also to actually for the code for code generation. So for instance, when we generate our SDKs, we do have contracts for those SDKs, and we actually generate a lot of code for those SDKs because of Smithy. Smithy is generating this code in those languages based on the contracts. So Smithy does support Java. If you are thinking, if you, for instance, have heard about this famous mandate by Jeff Bezos, I think it was 2002, when he said famously that right now everyone who wants to call code from any other team has to do it via service, via exposed service. And people who will not do that will be fired. So basically, Smithy is one of the enforcing tools which makes sure that this is actually being followed. And you have two important links here. So the first one on the left is actually to the Smithy tool, which is open source. And the other one is it's an awesome Smithy page where you have plenty of resources, how people use Smithy for code generation, contract validation, contract testing, all this kind of stuff. To be honest, I know that there were already many jokes today about DDD. To be honest, the good, sane approach to contract management in the organization solves 30% of the problems DDD promises to solve. That's my opinion. And feel free to challenge me after the conversation. Anyway, other basics, because we are still talking about the basics. So there are toolkits. There are toolkits for IDEs. There's obviously toolkit for IntelliJ IDEA, so something that you are familiar with. And what it really does is the typical thing. So there's a resource explorer, and actually for the infrastructure as code tool called CloudFormation, you can see the progress of how the stacks are deployed, so you can monitor it directly from your IDE. Of course, there is the direct access to logs. And there is some nice support for Lambda functions, but to be honest, I like the support in Visual Studio Code a little bit better. A little bit about that in a moment. You can. That's one interesting thing, because many of the relational database that you run on AWS, you actually can, instead of the native authentication, you can use IAM, so AWS native authentication for them. But how the way it works under the hood is actually generates temporary credentials. So it's actually quite cumbersome if you want to do it manually. So if you want to manually connect to the database, which actually has that IAM-based authentication. However, the way it's implemented in the toolkits, it's actually the toolkit takes care over it for you. So it's actually simplified a lot. And there is, of course, the support for Amazon Q Developer, which is a very fresh thing, and it was released like 2 weeks ago. And I will talk a little bit more about that later. Yes, I've mentioned support for the code, so there's also AWS toolkit for the code. And there's one super cool thing, but unfortunately this is very small, and you see it on the left. So it has a visual editor for the cloud workflows based on step functions, lambdas, and event bridge. So you can visually model your workflows, your serverless workflows in the cloud. So it's actually quite cool. All right, great. There's another service that I classify as a basic, and probably you should be aware of its existence. So it's called Code Artifact, and it's part of a bigger suite of services which are actually which are part of our development stack. And Code Artifact is basically your managed artifact repository. So if you don't want to run it like locally, like manage your artifacts, your jars, your packages, work with versioning and so on, you have this managed service. It does work nicely with Maven and Gradle. Of course, it supports all the corporate requirements like encryption, audit log, and so on. And it has a nice synchronization option with public repositories, so it's actually quite nice. Yes, we do have our own distribution of OpenJDK that you are probably aware of. No cost long-term releases, and it's just a drop-in replacement for OpenJDK. If you're interested in the whole story, that's probably a longer topic, and we are not going through it right now. Then the main idea is that that's the distribution that is like a default for all the runtimes when you are running some Java code in AWS without packaging the JDK, the JRE on your own. We are not really free riders, so we do contribute not only to Corretto, but also to general OpenJDK. So you see here our contribution to 21 as this orange box. So we actually contribute a little bit. We are visible. And it's really hard to say how popular is Corretto. One of the ways to actually find out how popular is it is by checking the information from other service providers. So there's a nice New Relics report for 2023, and it's obviously quite biased, and I will tell you why it's biased. And it says that based on the information that New Relic has, 31% of the Java instances that do use New Relic, that's an important remark, actually use this particular distribution, so Amazon Corretto. Why is it biased? Well, because most likely this is for cloud-native organizations, so the ones that use observability as a SaaS in the cloud are probably the ones which keep the rest of their stuff also in the cloud. So probably not the biggest enterprises. But still, it shows that the Corretto is not a niche, it's actually quite nicely adopted. So yes. So these are the basics. So most likely you've heard about them, at least about majority of them. So let's assume that you use Java, but you have to put it in some sort of compute resource. And you have obviously a few options, and the two main options that have sub-options are functions and containers. These are the two most popular ones. So maybe let's talk about the functions, so about AWS Lambda first. I don't want to get into too many details, but there are some things I have to cover. So if you take a look under the hood of how AWS Lambda is basically running, that's the general overview of the architecture. So actually, Lambda is completely event-driven. So if you just think about Lambda functions as a way to respond to HTTP requests, this is not a precise interpretation, because there may be many different sources of the events. You, for instance, can have a function running as a direct response to an operation on an S3 bucket. And it's like a completely legit. And there are many, many options for that. So you have the event coming, and then this event is getting mapped. There's some sort of a front end, which obviously is not a web application, but it's a way to register the fact that you've requested the function to be called. And there's some internal queuing, yes, because all those requests are being allocated to execution environments which are running within micro VMs called Firecracker. So that's the general overview of how it works. And it has implications. And those implications are visible at the top. Because when you have the request that you would like to have the Lambda function called, you need to pick well, it's not you, but where execution environment has to be picked. And the question, the issue is that not any execution environment, because the execution environment requires some sort of preparation. And that's the init phase. And this preparation has some stages, but basically what's important for you is that everything that has to be there for your function to run properly, for instance, the dependencies, or maybe some initialization outside of the handler function, happens during this initialization. And then, when this small execution environment is ready, you can invoke the function as many times as you want. And after some time of idleness, this execution environment gets deallocated and basically gets back to the pool so someone else can use it. So yes, all this optimization of the life cycle is actually taken care of by the AWS. However, this life cycle causes one small problem, which probably you know as a cold start problem. Cold start problem means that if there is no execution environment prepared for your function with your dependencies and initialization already done, the initialization has to be done. And the initialization time adds additional latency, and that's actually the cold start problem. So one of the major challenges or things to be tackled when it comes to optimization for Lambda is actually getting rid or reducing the time of this cold start. As I mentioned, Lambda functions are not really web-specific construct, or they are not coupled tightly to web applications or to any web frameworks. To be honest, too, if you are a Java developer and you want to run some code in a Lambda function, all you need to know is basically those free libraries. They provide you the basic concepts. You don't need frameworks. You can actually get rid of frameworks. Frameworks are heavy. So all you need are those free libraries. The first one is basically the handler interfaces and some information about the context. So you know at least who called you with what argument and so on and so on. So just the basics. Java events actually is for AWS native. So for instance, if yes, this request came from the S3 object, you know it is AWS specific information about this S3 object. And finally, yes, there is some support for JUnit if you want to run it. Okay, so let's talk a little bit about optimization specifically for Java. So you have those Lambda functions, and you actually don't want to spend too much money on that, and you want it to be efficient, and you actually care a lot about the cold start problem. And why? Because if you don't care about it, you may have some problems with spikish, unpredictable latencies, and if those spikish, unpredictable latencies stack up, for instance, in a complex microservice architecture, then you may get in some congestion problems and overall performance problems. So there are plenty of ways that you can use to actually optimize your Lambda functions on Java JVM, and here are just the major ones. And you can categorize them based on actually how much you can get, what's your ROI, so what's the effect, and also how much effort are they. So of course, the units on those axes here are not accurate. They are here just to give you the general overview. So what will take you more time, more effort, and what's the expected outcome. Let's go through some of them. Obviously, the first optimization is the right size, because it's when you define that you would like to call some code in a function, it's not enough just to have this code and compile it and upload the package. You also have to define how big will be your execution runtime for this particular function. And the way you do it is you don't specify the vCPUs and memory separately. Those are actually bound together. So you decide how much is actually allocated for every function instance. A function invocation instance. And there's one interesting thing that people keep forgetting about here on this slide, and this thing is on the left, is the number of vCPUs, is the number of virtual cores. Because people tend to forget, or they tend to assume that the function is actually single-threaded. So you should not be running multi-threaded processing in the function, which is wrong. Actually, you should use those cores, and you should remember that running asynchronous code may actually make a lot of sense. So even in case of running data or one or two cores, you should actually remember about this option. So, okay, I told you something super obvious. You should right-size your function, but like how to do that? So the good news, and something that people do not know about, that there's a tool for that. You can find it under this link. It's called Lambda Power Tuning, and basically it's a CloudFormation stack. You automatically deploy this stack, and what this stack will do, it will test your function with different potential values of the sizing of the function, and then it will basically visualize it for you to help you make the decision. So you don't have to do the optimization on your own. So this is nifty, and not everyone knows about this. So I recommend you to take a look. Another kind of optimization is actually people are not sure like what is the best way or best strategy for packaging functions. So the answer is actually very simple. The best strategy is uberjar. So you should actually package everything within one file. A single jar file is just faster to load for the Lambda. And yes, I know it's obvious, but keep the dependencies to minimum. Consider if you actually need dependencies like a web framework or not. Like for instance, putting Spring Boot on the top of Spring actually gives us even more overhead. The best way to actually do the packaging, there are plugins for that, there are tasks for that, you have them listed on the screen. So this is not something you have to do it manually. Basically, there are tools for all of that. Okay, so this was quite obvious. This is not that obvious. Okay, so tiered compilation is with us so for such long time that many people have forgotten that it exists, right? And it's actually default for some time. But if you, let's say, belong to the large population of people who care more about the cold start problem, the general optimization of the function, you should actually take a look at the third bullet point, that yes, you should make sure that a tiered compilation is enabled, but also you should make sure that you use only the C1 compiler. So that's the recommended setting to if you are really optimizing for the cold start. So that's an important thing. What else? This is actually underappreciated or not mentioned frequently enough. There is a dedicated HTTP client created by AWS, and this is optimized for being used within Lambda execution conditions. So it actually has a very small memory footprint. It's actually highly performant. So for complex orchestrations of microservices, such a small detail as using this CRT HTTP client actually makes the difference. I know that this graph on right is actually manipulated because it starts 125, but I've actually seen some good benchmarking data, and the memory footprint can be even few times smaller just because of using this small stupid library. So make sure that you are at least aware of its existence, and feel free to take a look. Like, testing it is not really a big deal. It's not really a big challenge. This was actually mentioned today already. And again, this doesn't get as much love as it should. So what is Lambda Snap Start? Lambda Snap Start is the mechanism which is very similar and actually coexists together with crack. So the whole idea here is that during the deployment, when you publish the new function version, so you publish, not you run it, but when you publish the new function version, what the micro VM, what Firecracker does, it creates the snapshot after the initialization, and it stores this snapshot, persists this snapshot, and then when the cold start happens, it actually doesn't run the initialization again, but it restores the snapshot. So that's how you can visualize that. And you see those steps I've mentioned in the top right corner. So after the first initialization, there is an optional pre-snapshot hook because it's actually crack compatible. And I've seen the crack code. I haven't done it myself, but I've seen the code for that, so it actually works. Then the snapshot is created, and then each time when the cold start happens, so the first request is being registered, the snapshot is actually being resumed. So it's actually a nice optimization that can make a huge difference and can save you a lot of time. And how to implement it or how to enable it, this is basically setting just one simple flag. So it's a very, very nice thing that you should not forget about. And yes, you can also have GraalVM native images for your Lambda functions. That's not a big deal. Then you, of course, don't need JVM. Basically, you don't need Java runtime when it comes to the way you configure your functions. Yes, of course, the normal consequences do apply, so some JVM features are not supported, but in general, the startup time for the function is significantly reduced. And yeah, so if we visualize it, we are just getting rid of the runtime. So in the normal version, we have runtime plus our code, and in this case, we have custom runtime and the code. Okay, cool. There is a library called Power Tools for AWS Lambda. This library has, I think, only 2 or 3 versions for each of them for one particular programming language, and Java is one of them. So what is this? This is actually a library, it's open source, and it's created by practitioners, so by people who have basically put in the library all the most popular practices that typically people re-implement, and they are so super popular that everyone should benefit, everyone should use them. And you have a few examples here. So there's some basic instrumentation for tracing and structured logging and custom metrics, so basically all observability. There is a small but nice mechanism to support idempotent operations, or Lambda, so that the Lambda doesn't get re-requested with the same parameters again and again and again, costing you money. There's a nice support for large messages where you only use the reference, and basically the payload is being offloaded to S3, and so on, so on, so on. So the link is here. The usage of that is actually super simple, and in this case I will show you a few examples for observability. Of course it makes sense, especially if you don't use OpenTelemetry, because if you use OpenTelemetry you do have instrumentation already, or if you have a framework with a strong instrumentation that you don't care. But if you just use the simple Lambda function, for instance, to deal with changes in S3 bucket, I've already mentioned it the third time, this is the way to go. So you just use the attribute, and then you have the information automatically logged, and basically by default it works with the cloud, with AWS native observability stack. So we have an example of the logged information here. Tracing, probably you're familiar, hopefully you're familiar with distributed tracing. So when you register the request, you are able to trace its sub-request to all the services it calls. So for instance, you have one microservice in Lambda, and it calls another Lambda, and all the way it requests some data from DynamoDB and from S3 bucket. So you would like to know the whole tree of processing. You would like to have one single identifier for this whole tree of processing, because for instance, you are looking for the bottleneck. You would like to instrument the code and see which part takes too much time, whereas actually you're constrained. So that's what distributed tracing helps you with, and obviously is, yes, the support is already here, and if you just use it, then it automatically generates trace information and identifiers needed for the correlation, and you can, for instance, read this information either in AWS native X-ray, or if you, for instance, forward this information through Prometheus in any other tool that is able to use to read the tracing information. Great, same for metrics. It's so simple. It's just one call where you can just do the put metric and create the custom metric that you can later inspect. In this case, it's in CloudWatch. Great. How does the idempotency work? It's actually very basic. Here's the sample. What you do is you define, like, how do you recognize that the request is the same? So you identify which parameters are meaningful to identify the request that is the same. And then it creates the hash out of those parameters. And if this entry does not exist, it puts the entry in the persistent store that you configure. In this case, it's DynamoDB. So this is how it works. So it can save you some money, and it can save you some processing time. Yep, and there are many other many other interesting quirks or small details in this library that you can use. So feel free to take a look at the Power Tools for Lambda. What about the containers? So famously, there's a meme on the internet that there are 17 ways to run containers on AWS, and I guess that by now there are probably more. I would like to tell you about one of them that you may be not familiar with. It's called AppRunner. And I would even ask you, make a poll, who knows about AppRunner, but I can't see you, so it doesn't make any sense. Anyway, what is AppRunner? So AppRunner is the serverless containers for web applications. So what you do, and why it's relevant for Java, is that what you do is you just have your Java repository somewhere, for instance, on GitHub, and you just indicate that that's my repository, and that's my branch, and few additional parameters. And what it really does, it takes care about everything else. So it does the compilation, it uses AWS native CI/CD stack, then it deploys it on Fargate, so serverless containers. It actually, you don't even have to create a Docker file. It creates those Docker files for you. It creates auto-scaling for you as well. You just set some boundaries, like, well, what are the constraints? So how much money do you want to spend most? This auto-scaling is actually very basic because you don't have to even know about any metrics like CPU or memory. What you do is you you basically describe your scaling in terms of the number of requests. And it also deals with the load balancing. So basically, all what you do is you specify the repository. And then if you configure it in a fully automated way, each time you commit to this particular branch, under the hood, the new container, the build, of course, is going on. The container image is being created, and this is being redeployed to your environment automatically in a blue-green way, which means that without the downtime. So it's actually nice, and it does support Java. It does support Java as one of the few runtimes. I think there are like 3 different runtimes. There's one for Python, one for JavaScript, one for Java, and I think that's about it. So it's something some people do not know. So if you want to know all the concerns that you don't have to care about, these are those blue boxes. So no runtime patching. You don't have to care about build, deployment, CI/CD, hosting, monitoring, encryption, nothing. It's all done for you. So it's actually the simplest way to run containers. And the good thing is that it actually scales to virtually 0. And why do I say virtually 0? Because when it scales down to the level where there is only one serverless container and there's no traffic coming, what it can do is basically it can free all the compute. It will just leave some memory. So the image of your application will resist in the memory, and you will pay only for that memory. And that memory is priced like 1/6 of compute or something. So it's virtually 0. So it's almost 0. Cool. But let's get back to all the standard way of deploying the containers on AWS, and how do we optimize when we have Java JVM code running with those containers. So yes, there are many options, and you see them on the screen, and some of them actually resemble the Lambda ones. So typically what you do, and this is not Java specific in any way, you just compress the layers. So just compress the image, and this is the simplest way, I think. You just create the build kit, then you switch it, and you just use it. However, there are more options. One of them is you can use Jeep. Jeep is created by Google. So this Jeep is actually quite smart, and it's not specific to any particular cloud. So what Jeep actually is about, it starts with a distroless image, and what it can do, because typically when you create an image of your application actually is just one layer, and this layer gets replaced each time, but in fact your layer consists also of the dependencies, which can be quite heavy. So why don't split it? So what Jeep can do is Jeep can actually split your application into several layers to make sure that this is actually optimized. And this is actually quite smart. There are some really nice effects, and it's actually very simple to run it, because as you can see, you can run it directly from Maven. So again, you don't have to like mess with many tools to get this effect. So it's nice. It has one drawback. So you basically regenerate it. It changes the way that you generate your images. So you have to rebuild the images that you already have. What other options are here? Another interesting option, which is actually which doesn't require you to regenerate your images, is called Sochi. I'm not even sure how to pronounce it correctly in English. Basically, it's seekable OCI. OCI is the basically containers the Docker is compatible with, so it's the name of the standard. So how does it really work? The way it works is that for already generated images, it creates manifests. There is a tool that is used to create those manifests. It's mentioned here. It's called, this Sochi Snapshotter. What it does, it creates the map of the image, and the map is used to index the image internally. Why so? If the runtime that will run your containers knows this standard, seekable OCI, and knows how to read those manifests, it knows where in the large image file each file exists. So for instance, downloading a whole image can take a lot of time. And normally, you have to wait until the whole image is downloaded. But when you use this mechanism, you don't have to wait, because you can use some of the files in a smart way. You can optimize, even if the file is still downloading, because based on your manifest, you know that this part of the file has already downloaded. So this is already supported by AWS, and you have the link in the top right corner. How does it work, for instance, with Fargate, so with serverless containers in Fargate. It's also nice, especially for the large images. So if you have small images, you probably don't care. But for large images, which always take some time to download, it's a nice thing. Again, another idea. Not sure if you use it, but I didn't know about it until some time, but that's a nice way to optimize. Created the custom JREs to deploy them in the cloud. So if you consider the standard JRE too large. So again, few basic steps. You, first of all, for your specific application that you have in this case in store string, you do generate the list of your dependencies. And then once you have it generated, based on that, you do create the custom JRE. And in this case, actually, you strip it out of everything that is not needed, including no header files, no man pages, and it's actually automatically compressed here, as you can see. And then what you do when you, as you can see, if you take a look at the first line, this one is the genuine Amazon Linux image, so it doesn't contain JRE at all by default. So what you do, you compare your, you copy your original jar file for your application, and you copy your custom JRE, and then you can run it in an entry point. So it's another nice way to actually reduce the size of your image. What about crack? So what about coordinated restore at checkpoint? So I've already mentioned this mechanism. This is the mechanism where you actually make a snapshot of the memory state after the initialization. So this will work for Lambda, but this will also work for containers. And this is very useful if you, for instance, work on a system that has to auto-scale aggressively. So imagine, for instance, that your auto-scaling is not predictable because sometimes you work in social media company or whatever, and sometimes there's an influencer starting a session, and this is something that you cannot predict. So your traffic rapidly increases, and you need to spin new containers, and you haven't pre-warmed them, and so on, so on. So in this case, the speed your container spins up is actually essential. So in this case, actually, Crack can help you a lot, and you have a link at the bottom of how can you use Crack with EKS. EKS is managed Kubernetes on AWS. Please keep in mind that Crack is still an experimental feature, so it's not supported by all OpenJDK distributions. So you should probably test it a lot if you really want to use it in production environments. Great. Yet another optimization. And this one is a no-brainer. I'm not sure if you remember this, but a few years ago when Apple has released the first MacBook Pro with the ARM processors, M1, like everyone was in awe, like, wow, this is so super fast. And like everyone's first thought, well, wow, this is super fast. But my second thought was, wow, if this is so super fast for my personal computer, can we get this in the cloud? And yes, we do have ARM processors in the cloud, and in AWS, there's already the 4th generation of those processors. It's called Graviton. And basically, they put it in everything they can. So this is in EC2, this is in Lambdas, Fargate, RDS, relational databases, Aurora, Elasticache, like literally wherever they can. If you're interested, and I think that actually what is specific for Java and why I mention it here is that this may be troublesome for compiled languages when you actually build native images and when you, for instance, have mechanism for static linking or dynamic linking. Because in this case, you may have libraries which are compiled for different architecture in different conditions, and it's actually much harder to do the testing and make sure that all your dependencies are also thoroughly ARM tested. But in case of Java, it's actually much more simple. If you want to take a look about the compatibility and about how to start, because like I said, this is a no-brainer, so you can start with the first link, getting started. And the second one is actually a porting advisor, which can help you to inspect your code, looking for some, I would say, unusual constructs, like calling some native code. Yeah, so if you are not fully sure about your code base and you would like to double check, this tool actually make a lot of sense and help you. Yes, and we do contribute a lot of improvements which are specific to ARM to actual JDK upstream. So we do this since, I think, JDK 17 or something. So yes, if you use Graviton, if you use ARM, please use at least JDK 17. Awesome. Let's get into developer tooling, because there are some nice tools that you can use as Java developer that can help you in whatever you do. And this is probably the most marketing slide I have. So there's something that has been released like very, very recently, and it was released literally, I don't know, 2 weeks ago. And probably you've known this previously as Code Whisperer, but Code Whisperer is just a part of that. So the thing is called QDeveloper. So when I said Code Whisperer, what comes to your mind is probably another code assistant, so another GitHub Copilot equivalent and so on and so on. So yes, that was Code Whisperer, but QDeveloper claims to be something more. Because first of all, yes, it helps you to write in debug code and so on, but it also helps you during the entire development lifecycle. So even outside of your IDE, and I will give you some examples in a second. And also, of course, has the full conversational mode when it can help you to describe the code that you already have. And it can help you with troubleshooting some stuff, which is actually quite impressive. So when is the Q, this icon in top right, when is it present? Well, it is present in IDEs, but also in the AWS console. So when you are in the documentation, when you're browsing docs for AWS, you can actually ask questions about the docs there, or how do I implement it? And it knows Java. It's one of the languages that are supported. It's obviously available in the mobile application for AWS console. It can be integrated easily. It's already created. It's already done with Slack and Teams. And if you are using the CI/CD stack, the whole building experience by AWS, it's also present there in Amazon Code Catalyst. Cool. So yes, the code, the asking the documentation is as simple as you can see on the screen. So basically, you have a chat, and you ask it. You get the references to make sure it's not hallucinating. So pretty easy thing. We do have like a huge, Amazon has a written culture. So we have a huge internal knowledge base when it comes to building applications. So it's trained on like 17 years of that internally. So it's actually quite nice. When it comes to the code assist, this is the experience that you know from similar tools like Tab9 or GitHub Copilot and so on. It can help. It can also converse with you about the code. So it can help you explain the code, so you can understand the code. If it's better, if you ask me if it's better or worse, you have to try it on your own. Everyone has their own opinion. I do have my own one. You can ask me after the conversation what I think about it. That's my favorite feature, and this is actually super impressive. It's called Amazon Q Developer Agent. It's my favorite because it's about agents, and I strongly believe that if GenAI will make a huge difference long term, it's because of the agents. So what does it do, and what is the example here? So what it can do is Q can run as an autonomous agent, so not in the conversation mode, but as a bot with some sort of a mission that you can ask for something. For instance, do you remember the discussion about Devin, the AI developer? So Q reportedly beats Devin in this SWE benchmark. So it can do such things, but it can do more. Why? Because it integrates with projects like, for instance, Open Rewrite. So there is a very nice experiment documented on Amazon website that actually agent, together with Open Rewrite, was used to migrate huge code bases, for instance, from Java 8 to Java 17. And literally, it was taking like, for projects that would never happen because that would take so much time, this was actually executed using agent, and the results were actually stunning good. So it's very, very nice. Open Rewrite, if you are not sure or if you haven't heard about it, it's a project, it's a pluggable architecture for code transformations that can be standardized. For instance, you can describe the rules of how to migrate the code, describe declaratively. Describe the rules of how the code from Java 8 can be migrated to 17. And this is done in the pluggable architecture, pluginable architecture of Open Rewrite. So that's one of the examples. This is something that may be super interesting for large enterprises with a lot of code smell and a lot of technical debt accumulated. What else? This is nice because this is present for quite a long time. So it doesn't only help you write the code, but it can also notify you about some security vulnerabilities in the real time. So that's actually very nice as well. It can provide you, it's of course aware of what OWASP Top 10 is, the full database of vulnerabilities, and it can provide you some suggestions for remediation. And yes, it's basically Java is one of the supported languages here. Great, and that's another feature it actually impressed me quite a lot. What it can do, it can help you troubleshoot errors. So for instance, you were setting up something and you've got an error in the console, and you can ask Q to help you troubleshoot this situation. So tell you, like, what am I missing? So when I started using this, like, to be honest, 90% of cases is about networking and access. Why don't I have this access? What policy am I missing? Or where I don't have network reachability? What basically I have to configure? So it's able not only to find out why you don't have the connectivity, but also to suggest you what to do to get this connectivity. So it's actually very, very nice, and it's also available. And why does it work? Because of one obvious reasons. It doesn't just know the programming language that you're using. It doesn't just help you to, by providing some suggestion which is like coherent with the project that you have, but it also knows the resources that you have in your AWS account. So for instance, you can have a discussion about a deep dive with this bot, with Q, about how I could potentially save some money, where is some space for optimization, or what are the orphaned resources that I've forgotten about because maybe they were not tagged by the automated mechanism, and so on and so on. So the fact that Q developers knows about your account resources is actually a nice benefit. Obviously, regardless of which frameworks they use, there are specific libraries for all the popular frameworks. So yes, there is AWS Spring I/O for Spring Framework. There's of course support for Micronaut, and also there are extensions for AWS services available for Quarkus. So if you're wondering how does the entry threshold for those frameworks on AWS look alike, it actually looks great. There's another AI-powered tool that you can use if you are a Java developer, because again, this one is limited for some particular languages. It doesn't work for all of them. And this one is not powered by GenAI, not by LLMs, but by traditional machine learning and by internal Amazon practices and Amazon information. It's called Code Guru, and it consists of two basic modules. So the reviewer and profiler. And to be honest, I've never used Reviewer, and it looks a little bit controversial, because what it does is actually comments your code. And by comment, I don't mean adding comments to your code, but gives you suggestions based on so-called best practices. So it has some best practices based on how Amazon creates code, based on how Amazon used AWS APIs, which is probably like more valuable, and also some security practices, for instance, OWASP that I already mentioned, or how to treat sensitive data. And it basically provides you some sort of a review, provides you suggestions of what you should change in your code. I haven't used this one. This may sound a little bit controversial, but it's also interesting. There is also a profiler, and this profiler understands intimately what you're running. So if you take a look here, you probably don't see it because those letters are really, really small, but it's able to, for instance, profile your memory to see that what kind of classes are consuming most memory, and so on and so on. So Code Guru Profiler knows JVM, and it's able to interpret the information knowing JVM. And it supports all the major compute options. So it's actually nice. All right, what else? CDK. CDK is a tool that doesn't get enough love, I would say. CDK is infrastructure as code tool. So just like Terraform, like Pulumi or CloudFormation. So why do I mention it right now here? because it does support Java. In this particular tool, you are defining your infrastructure, your cloud infrastructure, in your favorite programming language, as long as it's one of the few that are supported, and Java is one of them. So, for instance, as you can see here, what you do if you want to define the load balancer, use basically code application load balancer class, and you have the builder for that, and so on. This is basically Java syntax. So, why is it interesting? Well, for a few reasons. First of all, you can create all of those basic concepts with Java that you probably like more than YAML, but also it's multi-layered, which means that if it's Java, you can compose more sophisticated classes. For instance, there are already some resources that are on a higher abstraction level. Application load balanced Fargate service, which means that you're not provisioning just one thing, one service. No, you're actually provisioning like a full pattern. It's a Fargate service, and it's behind the load balancer. And you just define few parameters, and basically you have a standardized set of architecture, and this one is actually taken directly from the library, so it was created for you, but you can create such, it's Java, you can create them on your own. So basically you can just use one programming language for your whole backend stack, including the infrastructure as code. It's very, very nice. And like I said, it works on multiple levels of abstraction. And I'm getting close to the end. If you are very much into OpenTelemetry when it comes to observability, and you are worried that, okay, so my application, my framework supports the OpenTelemetry instrumentation, and right now I would have to somehow run it on AWS, the thing is that AWS actually supports very actively the OpenTelemetry project, and it has its own distribution for OpenTelemetry. And it's called ADOT. You see the link at the bottom. So basically, if you run Java applications in any container form or in Lambda, because for Lambda you have dedicated layers for that, then the integration of ADOT, the integration of OpenTelemetry is super simple. It's basically a matter of configuration. And then wherever you want to collect the OpenTelemetry observability information, it's totally up to you. You can use AWS native functions, or you can use like separate SaaS like Datadog, New Relic, whatever you want. If you don't love OpenTelemetry, if you have a traditional application and you just have JMX data and want to use, for instance, the cloud native observability stack on AWS, we also have you covered. Because it's actually very simple to integrate, to get this JMX data into CloudWatch by using collectd. It's actually very, very simple. And then you can enjoy having that in just one place, having all the observability data in one place. Brilliant. Some resources, if you want to take a look. Well, there's a laboratory, there's a lab, workshop, that will guide you step by step, and there are separate chapters, so if you want to try those techniques, those I've mentioned today and some more, some additional ones, like feel free. You can do it on your own AWS account, and it's designed in a way that will minimize your costs, so you can try this stuff on your own. There's another dedicated workshop, which is just for AWS Lambda, for Java, of course. So that's another treat if you are interested in building those serverless applications. If you already have an application in some sort of a web framework and you're running it on containers, on virtual machines, or on bare metal, and you are considering replatforming to serverless Java, it's another guide. It's actually a guide, not a workshop. So that's a guide that can help you with doing that, to make sure that you do it in as, let's say, smooth way as possible. And the topic of the containers and optimizing containers is actually a never-ending topic. And it's not like only Java, there are not only Java-specific optimizations, but we have a very nice white paper on that. So if you are using containers and if you feel that it increases your inertia and things happen slower just because of that, you can take a look at this white paper. It can give you some hints, it can give you some ideas on what you can do to speed up your containers in the cloud or not in the cloud. And yes, I know it was quite a whirlwind. I had more than 120 slides, and I already cut it by like 70%. Still, if you have any questions or if you want to discuss any of those, feel free to reach out to me. Like I said, if you like CTO Morning Coffee, feel free to have a high five with me later after this talk. Thank you very much. I hope you enjoyed the presentation and enjoy the rest of the conference. I don't think we have much time for questions, but let me check if there are any. Oh, yes, there's one question. Is Amazon Q Developer free? So they've released it like literally 1 week ago, and I don't remember if anything changed in the licensing. And thank you very much, by the way. It's a great question. As far as I know, the Q Developer, or at least Code Whisperer area, it was free for the personal use. So, and not even personal, for individual use, I think. I think this is the way they phrase it. So if you want to use it for a larger, on a team level, then you have to pay it, then it's paid. But I think that for the individual work, it's free. You have to double check this, and I can double check it for you later, but because I'm not sure if they changed something in the licensing. But it was free for the individual use. And one more thing, I think that they've added a very hefty trial as well. Why? Just because this name, this brand is new and not many people have heard about it. So they've added the trial to give people more time to try the tool. So yes, hopefully you can enjoy it for free. Do we have any more questions? Nope, we are out of questions. Thank you very much. Take care.